You have a memory of this morning. You have an expectation of tonight, and somewhere in between, you have the feeling that you are moving through time, that the present is a knife edge sliding forward, that the past is behind you and the future is ahead. That feeling is almost certainly wrong. Not in the vague philosophical sense, in the precise, mathematical sense. The equations that physicists use to describe reality at the deepest level, the equations that govern particles, fields, gravity, and the structure of spacetime itself, do not contain a flowing present. They do not distinguish between past and future, and in some formulations, they contain no time variable at all. The question physicists are now seriously grappling with is not whether time travel is possible. It's whether time exists in any meaningful sense, and what it means for you if it doesn't. It starts with Einstein, and it starts with a letter. In March 1955, Einstein wrote to the family of his oldest friend, Michel Besso, who had just died. He wrote, for those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. That sentence has been quoted so many times it has almost lost its weight. But read it again slowly. Einstein, the man who understood the structure of time better than anyone who had ever lived, is telling a grieving family that the moment of their loss, and every moment before and after it, exists equally. That Besso is not gone. That gone is not a category physics recognizes. This is not poetry. It is a direct consequence of what Einstein's theory of relativity actually says about the structure of reality. In 1908, mathematician Hermann Minkowski fused space and time into a single four-dimensional structure, spacetime. In his words, henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. What this means is that every event, your birth, your death, the formation of the sun, the last star burning out, occupies a fixed location in the four-dimensional block. The past has not vanished. The future has not yet arrived. All of it simply exists, permanently, simultaneously. Physicists call this the block universe, and it is the dominant interpretation of what relativity is actually describing. There is no universal now. Two observers moving at different speeds relative to each other will disagree about which events are happening simultaneously across space. There is no way to reconcile their disagreement. There is no privileged present moment that both can share, which means the present isn't a feature of reality. It's a feature of you. But if the block universe is right, if past, present, and future all exist equally, then why do you experience time moving in one direction? Why does an egg break and never reassemble? Why does your coffee cool and never heat itself back up? This is the question that has occupied physicists for over a century, and the answer is both simpler and more disturbing than most people realize. Almost every fundamental law of physics is time-symmetric. The equations that govern particles moving and colliding look identical, whether you run them forward or backward. Gravity doesn't care which direction time flows. Electromagnetism doesn't care. Quantum mechanics doesn't care. If you filmed a collision between two billiard balls at the subatomic level and played it in reverse, the reversed film would be physically valid. There would be no way to tell which direction was forward. The one exception is entropy. The second law of thermodynamics says that disorder in a closed system tends to increase. An egg breaks because the broken state has vastly more possible arrangements of atoms than the unbroken state. And systems naturally drift toward states with more possibilities. This asymmetry, entropy always increasing, is what physicists call the arrow of time. It's the only arrow. Every other law points in no direction at all. But here is the deeper problem. Why does entropy increase? Because the universe started in an extraordinarily low entropy state at the Big Bang. The order we see around us, galaxies, planets, exists only because the universe began in a condition of almost incomprehensible organization. Physicists call this the past hypothesis, and it means the direction of time isn't written into the laws of physics. It's a boundary condition, an accident of where we happen to be in the history of a universe that started very ordered and is slowly becoming less so. The arrow of time is not fundamental. It is statistical. And at the deepest level of reality, there may be no arrow at all. This becomes most explicit when you try to combine quantum mechanics with gravity. When physicists attempt this, the central unsolved problem in all of physics, they arrive at an equation called the Wheeler-DeWitt equation. It describes the quantum state of the entire universe, and it contains no time variable. None. The equation essentially says the total energy of the universe is zero, and the wave function of reality does not evolve. From outside the system, nothing changes. The universe is frozen. Physicists call this the problem of time, and it is not a mathematical quirk. It is a fundamental feature of what happens when you try to write down the most complete description of reality that physics can produce. Carlo Rovelli, one of the founders of loop quantum gravity, spent years working through what this means. His conclusion, in his book The Order of Time, is that time is not a fundamental feature of reality. In his words, there is no time variable in the fundamental equations that describe the world. What we call time, he argues, is emergent. It arises from our perspective as observers inside the system, from entropy gradients, from memory, from the particular thermal state we happen to be in. Time is ignorance, he writes. It is the expression of our incomplete knowledge of the state of the world. Julian Barbour goes further. In his book, The End of Time, he argues that time does not exist at all. Reality is a vast static collection of instantaneous configurations, what he calls nows, each one complete and self-contained, each one containing records of what looks like a past. There is no river of time connecting them. There are only the configurations themselves, existing timelessly in what Barbour calls Platonia. What you experience as memory is not a record of a journey through time. It is information encoded in your present configuration that makes it look like there was a journey. You have never moved through time. You have only ever been here, in this moment, which contains the appearance of everywhere else. But if the universe is fundamentally timeless, if the Wheeler-DeWitt equation is right, then how do you experience time at all? The answer may come from quantum entanglement. In 1983, physicists Don Page and William Wooders proposed something remarkable. They suggested that time emerges from the relationship between entangled quantum systems. Globally, the universe is static, satisfying the Wheeler-DeWitt equation, frozen, timeless. But internally, an observer who is entangled with a clock system sees that clock evolve. Time, in this picture, is not a background against which things happen. It is what it looks like from the inside when parts of a timeless universe are correlated with each other. In 2014, physicists at a laboratory in Turin illustrated this experimentally using entangled photons. An internal observer, one entangled with the clock, saw the system evolve. An external observer, one looking at the global state, saw nothing change. The conclusion of a 2021 follow-up paper was direct. There is only one time, and it is a manifestation of entanglement. Your experience of time passing may not be a feature of the universe. It may be a feature of being inside the universe and entangled with it. And your brain confirms this. Neuroscientist David Eagleman ran an experiment where subjects fell 31 meters in a controlled free fall while wearing a device designed to test whether the fear response actually slows down perception. It doesn't. The subjects could not read anything during the fall that they couldn't read normally. But afterward, they remembered the fall as lasting 36% longer than an equivalent fall they had watched. Time slowing down in frightening moments is not a feature of perception. It is a feature of memory. Your brain lays down denser records of high-stakes events, and when you replay them, they feel longer. The past is not what happened. It is what your present configuration encodes. Rovelli and neuroscientist Dean Boanomino concluded in a joint 2022 paper that our vivid sense of flowing time arises from entropy gradients and memory traces, from the structure of information inside us, not from the structure of time outside us. So where does this leave you? You are sitting inside a universe that, at its deepest mathematical level, contains no time variable. The equations that describe reality most completely describe a frozen block in which every moment exists simultaneously. The direction you experience time moving is a consequence of where the universe started, not of any law that governs where it goes. And the flowing present, the knife edge you feel yourself moving through, is something your brain constructs from memory, entropy, and the particular configuration of matter that you happen to be. Einstein wrote to a grieving family that the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't comforting them with philosophy. He was telling them what the physics actually says. Besso is not gone. The moment of his death exists as permanently as this moment does. Every version of you, younger, older, the one reading this sentence, occupies a fixed location in a structure that does not flow and does not end. The universe doesn't experience time. You do. And the question nobody can fully answer yet is what that difference means.